All right. So again, just a reminder, homework needs to be posted. It is attached to this. So let's take a look at our first new vocabulary. Okay. All right. So this says we're going to talk about inductive reasoning and conjecture. So it says inductive reasoning is a type of reasoning that reaches conclusions based on a pattern of specific examples or past events. A conjecture is an unproven statement or rule that is based on inductive reasoning. Okay? Questions about the vocabulary? Yes.
So the first one, what is the second one? Unproven statement or rule that's based on?
Wait, say that one more time.
Like, what is the second one? The first one. That's kind of like, what is the second one?
A conjecture? It's basically stating that you usually use inductive reasoning based on conjectures, and you can't prove it for, if you can't prove it for anything, it can't be proven in general. So even though you identify a pattern, unless you are going to go all the way to infinity with that pattern, you can't prove that it's completely true. So we just have to kind of assume that it's true. Does that make sense?
So that's conjecture.
Yeah, that's what the conjecture is.
True. That's true.
Exactly. We're just going to assume it's true pretty much. All right, so let's take a look at example 1. So we have here, using the pattern 3, 6, 9, 12, answer the following. So what's the pattern you observe? Someone tell me. Yeah, everything we are, okay, so 3 is added to the number before. Please be quiet. Someone tell me what's the next term in the pattern. So if we're adding, I'm sorry?
Wait, next number 6.
All right, so if 3, 6, 9, 12, we add 3 to 12, what does it give us? 15. Very good. So now the question here is, what's going to be the conjecture? What? All right, and then is it 1 or 2, and why? So remember, it's a statement that is based on inductive reasoning. So which one is it going to be? 1 or 2? No? 1. Very good. It's going to be 1, okay? And this is because it is the statement based on inductive reasoning. From 2. Okay? So think of it this way. Pretty much if you're writing it in words, it's your conjecture. Okay? All right, so let's take a look at the you try it. So it says, identify the pattern and state the next 2 terms. So the first thing is, let's identify that conjecture. So what is the conjecture here? I heard,
6.
yeah, what are we doing specifically with the 6? We're subtracting 6 each time. So subtract 6. From the previous number. And then they're asking for the next 2 terms. So the terms are what? What'd you get? 58, 52. All right. Letter B. What's happening here? We're dividing by 2. So the conjecture is dividing the previous term by 2. And what are the next 2 terms? 50 and 25. Perfect. Try C on your own. All right, someone tell me. What's the conjecture? It is 28. The term is 28, but what are we going to say? Yep. Okay, so it adds by 1 starting with the 3. So in this case, you're adding 1 more than what was added to the previous number. Okay, so you're basically adding 3 and 4 and so on. And then we already have the next term. So we're talking about that 5th term. And that would be 28 then. Okay? Any questions? Anything I can address before we move on to the next page? All right. Let's move on then. All right. So it says, let's talk about what a counterexample is. It says a counterexample is an example that shows a statement or conjecture is false. So a conjecture can't be proven unless we can actually do everything. So those patterns you found, right? We would have to prove that every single one, like follow the pattern all the way to infinity in order to prove this correct. And that's not going to happen, right? It'll never be accomplished in a lifetime, 2 lifetimes, or even a million lifetimes. So what we can use is, if we want to prove a conjecture false, we need to provide a counterexample to say, hey, this exists, which goes against this conjecture, and therefore the conjecture has to be false for everything then. Okay? So a conjecture can't just work for one part or two parts. It's got to work throughout to be true. So if we can provide that counterexample proving it false, then we know, hey, it's no good. All right? All right, so for the next part, it says for a conjecture to be true, it must be true for every possible case. So if a counterexample is found, the conjecture is false. Is anybody still writing this down? All right, let's get into the example. So this says, if a conjecture is true, write true. If the conjecture is false, write false and provide a counterexample. So looking, all prime numbers are odd. First off, true or false? False. All right. It's definitely false. What's the counterexample? Now, prime number is something that's only divisible by 1 in itself. So what even number is divisible by 1 in itself only? 2. 2 is prime. Even though every other example we do, it's going to be odd, right? 2, 3, 5, 7, 11. But that 2 disproves this conjecture. All right, all quadrilaterals of equal length are squares. What do you guys think? True or false? It's actually false. Who's got a counterexample for me? Good. So a rhombus. Yep, we call that a rhombus. So a rhombus is equilateral, which means all the sides are equal. Okay, so it's a rhombus. All right, let's take a look at number 5, or part 3, I mean. If a fraction has a denominator of 4, then the fraction can be reduced. If a huh?
Yeah, true.
You're thinking true? Okay.
Those two.
What? I'm sorry?
Those are like subtracted. Or like,
Division?
yeah, divided by 2.
Okay. I can see that. Anybody got something else? So remember what they're saying. If a fraction has a denominator of 4, then the fraction can be reduced. That means it's true for out. Is there a counterexample to that?
What 2 be?
No, not 2. That would be 2 over 4. What do you think? 3 over 4. Can 3 over 4 reduce? No, so this is actually what? It's false in this case. And that counterexample, 3 over 4. I think I had 1 over 4. That works too, right? 5 over 4. 7 over 4. If you have that odd number, that can't reduce. All right, what about this last one? All even numbers are divisible by are divisible by 2. True, 100%. All right, why don't you guys try try it? Okay? If a conjecture is true, write true. If the conjecture is false, write false and provide a counterexample. Everyone who lives in Texas lives in Houston. And orange is the only fruit that is also a color. All computers have touchscreens. And if a fruit is a fruit, if a food is a fruit, then it is a peach. Go ahead. Why don't we finish this and then because we're almost done. Okay. And then if you need some time tomorrow, we can.
Grapes. Yeah, they're colored grape. Yeah, grapes are colored.
Nah, you got it, bro. You got it, bro.
Grapes a color?
Top tier.
Because there's green grapes, there's red grapes. I don't know how it's a color. But
Oh, what do you also call blueberries?
Blackberries.
but is that a color?
Like exactly orange. You know.
You know what I mean? Is blackberry a color?
I mean, you
But you have the evidence that shows that blackberry is a color. I would view that as more of a dark purple. Do you know what I mean? It does? I've never seen the color grape and Crayolas line up. Let me check. Obviously, if it's true, you have your counter example.
Orange, red, like yo, what'd you say? Nah. When I say it's there.
Color name. It is in the Crayola lineup. You're good.
It's true, bro.
So it's false, right?
Well, actually, I'm not going to lie. I was going to do that as my true statement, but you have a counter example, so technically it's false.
Right. That's crazy, bro. Not all answers is false.
Yeah, now all the answers are. You're right. I mean, if he can, it works, right?
A crayon, bro. Why? A crayon, bro. Oh, bro. That shit count, bro.
I think I'm going to change it to a primary color. If we do a primary color, then it would be true. That would be the. Okay, should we go over these? Yeah? They're pretty easy. Okay. So everyone who lives in Texas lives in Houston. True or false? False. Give me a counter example. Where could somebody live in Texas? Dallas, Austin. Yes. Dallas, Austin. We have family that lives in Abilene. All right. An orange is a fruit.
Oh.
Okay, so here's the situation. Yes, if you're talking just primary colors like your orange, your yellows, your blues, it would be true. However, in the Crayola universe, because I just looked it up, it is false. And remember, it has to be true consistently throughout. So if we find that counter example, it's false.
I think this statement says if a vegetable has seeds, it's considered a fruit. Is that a vegetable?
Well, vegetables and fruits both have seeds.
I know, but somebody told me like if they have seeds, they're automatically like a fruit.
No. That would be false. The counter example green peppers. Green peppers have seeds, and that is considered a vegetable. Yes.
Pepper is a fruit, bro.
Yeah, peach is a color too in the Crayola universe. So in this case, someone said grape, peach. I don't know if blueberry is a color. I'm not going to look it up. Yeah.
Is peppers a fruit?
Peppers?
Yeah.
No, they're a vegetable.
They're fruit.
They're vegetable. Vegetable.
You're a top tier, bro.
Because I'll give you another counter example. Squash. Squash is not a fruit or a vegetable. It is squash. It's its own category, and it has seeds. Pumpkins, zucchini. Pumpkin is not a fruit. Pumpkin is squash. It's its own category. Guys, I know this. I garden like crazy. Like I have so much. You should see my garden. It's literally a quarter of this room. It's crazy how big it is. Yeah, I'm actually growing pumpkins. I have 6 pumpkins so far, maybe 7 here pretty soon. Yeah, legit. I grow them every year for my nieces and nephews.
They're gonna be grown in time.
We don't eat it. We just carve them at Halloween.
You got enough time to grow.
Yeah, I put them in at the end of June. Yeah, I'll bring pictures tomorrow. Seriously, no joke. I got tons of pumpkins. I had tomatoes. I have squash. Huh? I'm trying to. What we've done is, like, when we first moved into this house, we bought a pumpkin and we kept the seeds from that one pumpkin, and I've just been growing the plants ever since. So it's we call it like a generational garden.
How much, like, is like yard pretty big?
It is. But my garden bed, my husband built me a garden bed and he keeps expanding onto it for me. It only takes up about maybe a 16th of my yard. I've got a very big backyard and a very big front yard. Huh?
Yeah, I don't know, like 16.
I've got about half an acre between my front and my back.
Half the acre is crazy.
It's really big. Yeah. Yep. The house stinks, but the amount of land I got is pretty awesome. All right. All computers have touchscreens.
No.
False. Give me a counter.
Like this.
Yeah, this.
You grow grapes?
No,
Is it
they're
hard
too.
to?
Yeah,
Like, how hard?
very. You have to have somewhere for it to crawl up, and I don't have the structure for it. I grow green beans. I grow tomatoes, butternut squash, pumpkins, yellow squash, zucchini. Did I say green beans? I said green beans, right? Snow snap peas. It's like really sweet peas. Like they come in the pod, you open up, they're really good. Basil. What else? Spinach. No, carrots are a real pain in the rump. I tried it last year. It didn't work out. I tried broccoli last year too. I didn't like it either. I tried onions last year. It didn't work out.
Onions are my favorite.
So you eat it by yourself?
I did that last year. No, I will never do it. I will try the other ones again. I will never try watermelon again. It is so. I did that for my husband. It is so picky. No. And by the end of the season, it was literally November, and we finally got something, but they were like this big. No, never again.
What about blueberries?
Huh?
What about blueberries?
Blueberries need a vine too. That's a tree usually. That wouldn't be in my
I saw
garden.
this one thing on TikTok where, like, they took a seed out of the lemon.
Yeah.
And they grew it, and like it grew another lemon.
Yeah,
It's actually true.
that's what I do with my pumpkins. Yeah, yeah. I bought a pumpkin the first year we moved into the house. Scooped out the seeds, put them on the side, let them dry out, and then I planted them 2 summers ago. And then I got another pumpkin. We carved that one, took out the seeds, and now the pumpkins I'm getting now are it's a generational pumpkin. Garden's done. Yeah. The basil comes in because I can still use that, but
You don't cover up like the mark where all this stuff is.
no, because I get so much of it. Like you should see it. Like I make my own spaghetti sauce because I have so many tomatoes. Yeah, legit. I have to freeze it. I had to give some to my dad. It's crazy how much tomato sauce I've got. But yeah. Yeah, Mrs. Smith does a lot of gardening.
Is it a big, like, you know that?
It's pretty easy. The only thing I don't like are my squash beetles. Those little gray bugs that come, they ruin my zucchini, but I already got like a ton of zucchini out of it. So I love zucchini. All right. Counter example would be your own laptops, right?
No, mine's touchscreen.
Well, when you get the loaners, they're not, right? Some are. All right. If a food is a fruit, then it is a peach. False. Counter example? Apples. There you go. All right. Any questions? All right. You see this? This is your homework.
All of it?
All of it. 2 pages. Take a picture. Get it done before the bell rings and you're done with everything. Take a picture, put it on Google Classroom. Finish it first, and then you can get your phones to do that, okay? All right. Those who are watching at home, have a great day.